Okay guys, continuing on from the previous video, we're now going to look at if we have the magnitude and the direction of a vector, how we can find those horizontal and vertical components. So the formulas would be the horizontal component would simply be the magnitude times the cosine of the angle of the direction, and the vertical component would be the magnitude times the sine of the angle. And that will give us those vertical and horizontal components. So here's an example. An airplane is flying 300 miles per hour in a direction that is 30 degrees north of east. So this 300 miles per hour, that is the magnitude. So we'll call this vector v, but that is the magnitude of v. And then the 30 degrees north of east, that's our direction. You do need to pay attention to, a lot of times the direction will be given in terms of a compass direction, and we need to make sure we know what that means. So 30 degrees north of east means we start east and we go 30 degrees towards the north, which would be up here, right? So that is the angle that we're looking at here. So don't automatically assume that it is the angle 30 degrees, because if it were different directions besides north and east, in any different combination here, it's not talking about the angle 30 degrees. So you need to be very careful with that. This is talking about the angle 30 degrees. So the question is, what are the north and east components of the velocity of the plane? You should understand, hopefully, that the majority of the speed is going to be in the east direction because it's only 30 degrees to the north. So most of the plane would be going, the horizontal component should be much larger than the vertical component. We should see that through our answers. So what we're going to do is, to find the horizontal component, we are going to do 300 times the cosine of 30 degrees, and to find the vertical component, 300 times the sine of 30 degrees. So the horizontal component, we're going to get 300 cosine of 30 degrees is root 3 over 2. So that's going to give us a horizontal component of, if we do the 300 divided by the 2, we're going to get 150 square root of 3. You could give me the decimal equivalent there. That's fine as well. B is going to be 300 times the sine of 30, and the sine of 30 is a half. So that's going to give us 150. So the component form of this velocity vector of this airplane would be that 150 root 3 is its horizontal speed, and the vertical or the north speed here is 150. Again, feel free to give me the decimal equivalent to that 150 root 3, and that may make more sense. Okay, the dot product. So this one is where it's a little bit confusing in terms of operations with vectors. If you see this u dot v, okay, we're going to call that the dot product. The way I'm going to say that is u dotted with v. U dotted with v is not simply just multiply the two components and then leave it as a vector. What you do is you multiply the horizontal components, and you also multiply the vertical components, and then you add those two things together. So it's important the dot product is not going to be a vector. It is going to just simply be a number. That's it. So I have two vectors here, u and v. Vector u is 3, negative 2. Vector v is 4, 5. And I want to find the dot product of u and v. So what we're going to do is u dotted with v would be the horizontal components multiplied together plus the vertical components multiplied together. And so that would give us 12 plus negative 10, which would be 2. Again, notice how that is not a vector. It is not written like this, right? It's not component form. It's simply a number. It is a scalar, not a vector. We have this thing called the dot product theorem, which we're going to use down here to find the angle between two vectors. But the idea is the dot product of two vectors is also simply just going to be the magnitude of each one multiplied together times the cosine of the angle in between them. So if I did know the angle in between two vectors, I could simply just do the cosine of that angle, and I could do multiplied by the magnitude of each one, and that would give me the exact same answer as what I got for the dot product. This equation, simply manipulated around, leads to this, right? So if I were to solve for the cosine of theta, I end up with this. And this is telling us that if I want to find the angle between two vectors, I do their dot product on top and I divide by the product of their magnitudes. Okay, so this is what I'm going to use in this example below. The question is, what is the angle between these two vectors u and v? So I have to do two things. Again, I have to find their dot product. So u dotted with v is multiply the horizontal components, multiply the vertical components, add those things together. So that's going to give us 8 plus negative 15, which would be negative 7. And then we are also going to find the magnitude of each one of these. So the magnitude of u is going to be 2 squared plus 5 squared. Take the square root of that. So that's going to be the square root of 4 plus 25, which would be the square root of 29. And we need to find the magnitude of vector v, which would be the square root of 4 squared plus negative 3 squared, which would give us the square root of 16 plus 9, which would be the square root of 25, which would be 5. Okay, so that all leads us to now being able to use this formula. So the cosine of the angle in between these two vectors is going to equal the dot product, which is negative 7, divided by the product of the two magnitudes. So this is going to be 5 times the square root of 29. And then what you need to do to evaluate for the angle is simply just do the inverse cosine. So I'm going to do cosine the negative 1, right? That means the inverse of this negative 7 over 5 square root of 29. And that will give us the angle. So you could use Desmos to do this. You could also use a TI Nspire. I know that you probably don't have one with you, but let me just show you in Desmos really quickly how we could figure that out. In this calculator button down here, you will see an option for functions, and we want to do inverse cosine, and we had negative 7 divided by 5. To get square root, the easiest way to do that is put SQRT, and it turns into a square root. 29. Now, this answer is dependent upon what setting we are in. So if we are in radian mode, that will be a radian answer. It's probably going to make more sense for you if we do degrees, so we switch that to degrees, and now I see my answer is 105 and some change. So the answer to this, the angle between these two vectors, is approximately 105 degrees. Okay. The very last thing here is how to determine if two vectors are perpendicular. And two non-zero vectors, u and v, are perpendicular if and only if their dot product is equal to 0. And I could get into the math behind that. It should make sense that if the dot product is 0, the number up here is 0 on the top of this fraction, which means that whole fraction is going to be 0. And think about where cosine is 0, and that would make sense in terms of the angle between the two vectors. Okay, it happens at 90 degrees, by the way. So, determine whether the vectors in each pair are perpendicular or not. I'm only going to do one of these examples, but the idea is if I do the dot product and I get 0, then yes, they are perpendicular. So u dotted with v in this case, we're going to have 3 times 2 plus 5 times negative 8. This very, very clearly will not give us 0. We get negative 34. So these are not perpendicular. Not perpendicular. I think that if you look at the vectors here and you try that yourself, you're going to see that the dot product on B is going to give you 0, and therefore it's going to be perpendicular between vectors u and v for question B. Okay, so again, like I said, a lot of stuff covering vectors here. There are tons of different concepts, but I hope that individually each one of those things is not too difficult as I scroll back up through this. There's just a lot of different concepts again, but it's all dealing with vectors and how we're going to use those. So if you have any questions, again, make sure you sign up in the Google Sheet for some office hour help. The homework this time is going to be a little bit different. I'm going to give you a worksheet that is multiple choice, and then there will be an attached Google form for you to fill out your answers. So stay tuned for that. Make sure you check that tasks assignment in its learning to make sure that you know what you're supposed to be doing and how you are supposed to be doing it.